If we shrink Earth down to the size of a basketball, the Sun in comparison would be as large as 2 Hollywood signs stacked on one another. Impressive, right? That is, until you remember that our star is just a yellow dwarf, and out in the universe there are supergiants in front of which the Sun looks like a mere speck of dust. In 2024, scientists identified a true cosmic monster, a supergiant star so massive it could swallow the Sun along with half the solar system. So who is this new record holder? Why is size not the biggest deal in space, and what does it take to claim the top spot in the universe? The largest star in our night sky after the Sun is not Polaris. In fact, it's the lesser-known Doradus, located in the constellation of the same name. It can only be seen from Earth's southern hemisphere. In 2024, for the first time in history, scientists managed to observe the surface of this star in detail, and it didn't disappoint. They discovered that the scorching plasma on Doradus is literally boiling, forming giant bubbles. And since the star's radius measures nearly 300 times our Sun's radius, the bubbles on its surface could be as large as our star. Yet even though Doradus is the largest star in the night sky, it's far from the largest in the universe. Until recently, that title belonged to UY Scuti. In 2012, astronomers used the Very Large Telescope in Chile to measure 3 supergiants at the center of our Milky Way. Among them was UY Scuti, whose radius stunned scientists. It measured 1,708 solar radii. But don't assume this star is just 1,700 times larger than the Sun. Let me explain how that really works. Here are 2 cubes before you. The side of the white one equals 1 solar radius, while the side of the gray one equals 2. Even though the gray cube side is only twice as large, it can fit 8 white cubes inside it. This principle applies to other 3D objects like stars. That means the star UY Scuti could hold almost 5 billion of our suns, or at least it could have, if scientists hadn't made a mistake. In 2023, new measurements revealed that the star's radius was actually just 900 solar radii. So in 2024, the title of the largest star in the universe went to WOHG 64, whose radius is over 1,200 times larger than our Sun's. This colossal star resides in a neighboring galaxy, the Large Magellanic Cloud, located 60,000 light-years away from us. Fortunately. I mean, if we place WOHG 64 at the center of our solar system, it would engulf 5 out of the 8 planets, including Jupiter. WOHG 64 is surrounded by a massive dust and gas cloud formed by an intense stellar wind blowing material off of the giant. This dust cloud, with a mass of 9 of our suns, stretches across a full light-year. So, WOHG 64 rightfully holds the title of the largest star, or does it? Here's the twist. There's a star much bigger than WOHG 64, yet scientists seem to ignore it. That star is the red supergiant Stephenson 2 DFK1. Its radius measures 2,150 solar radii. But despite its massive size, scientists seem to overlook it, and there's a reason. Stephenson breaks the laws of physics by exceeding the so-called Hayashi limit twice. To prevent it from being torn apart by internal plasma pressure or crushed into a white dwarf by its own gravity, the star must maintain hydrostatic equilibrium, a delicate balance between gravity pulling inward and pressure pushing outward. This balance defines the relationship between a star's mass, radius, and temperature. Yet Stephenson breaks 2 of these rules, the limits on both radius and temperature. While the maximum temperature should be 3,500 K, Stephenson's surface temperature is only 3,200 K cooler than the coldest known supergiants. This suggests there must be an error either in Stephenson's measurements or our understanding of the laws of physics. For now, WOHG 64 still holds the title of the largest star in the universe. But here's the thing, its title isn't just about size. Stars are also classified as hypergiants, not based on size but on their luminosity. In space, size isn't the only thing that matters. Do you want to see the real record holder in our universe? Here it is. This is our 136A1. The radius of this star is just a little over 42 solar radii, but it's a champion in a completely different class. Our 136A1 is considered one of the heaviest, brightest, and hottest stars out there. Its mass is almost 200 times that of our Sun. It holds the title of the second most massive star in the known universe, only surpassed by its neighbor in the Tarantula Nebula BAT 99-98, whose mass exceeds the Sun's by 230 solar masses. But these titles won't last long. Both stars are being stripped by intense stellar winds. For our 136A1, these winds reach a mind-boggling 2,600 km per second. Because of this, the star loses over 3 quintillion kilograms of mass every second. Scientists estimate that since its formation, it has already shed about 35 solar masses. Its luminosity is equally stunning, almost 4,777,000 times that of our Sun. If our Sun were this bright, the temperature on Earth would rise to an insane 16,200 K. That's almost 3 times hotter than the Sun's surface. But our 136A1 ranks only 7th in the universe in terms of luminosity. The title of the brightest star belongs to Godzilla from the Sunburst Galaxy. It's brighter than the Sun by an unbelievable 255 million times. But our 136A1 could easily beat this monster in the race for the hottest star. Its surface temperature reaches around 46,000 Kelvin, which is about 1.5 times hotter than Godzilla and almost 8 times hotter than the Sun. Yet even our 136A1 doesn't come close to the champion in this category, the true master of extreme heat. This sun-eating, light-consuming star with a radius half that of the Sun is WR102, and it just might be one of the most dangerous stars in space. Its extreme stellar winds strip off mass hundreds of millions of times faster than the Sun sheds its own. These raging winds, along with powerful ultraviolet radiation, compress and ionize the surrounding interstellar matter, forming a bubble-like nebula around the star. All of this is due to the star's scorching temperature, which reaches about 210,000 Kelvin. If our Sun ever got that hot, it wouldn't just boil away the oceans and atmosphere, it would vaporize most chemical elements on Earth. Scientists suspect that WR102 is nearing the end of its life and could soon explode as a supernova, surrendering its title as the hottest star in the universe. Although our 136A1 didn't take the crown in any specific category, its rare combination of mass, brightness, and temperature makes it truly one of a kind. But just like the Guinness World Records, where next to the heaviest weight ever lifted by a human, you'll also find a record for the longest walk on Lego bricks ever completed. The universe has its own weird champions and underachievers too. If you thought that colossal stars with radii thousands of times larger than the Sun's are the most mind-blowing things in space, think again. In fact, being the smallest in the universe is a far greater challenge. But this star with an extraordinarily long name, EBLMJ0555-57AB, seems to pull it off. Its radius and mass are just 8% that of our Sun. It's the smallest star known to humanity capable of sustaining nuclear fusion in its core. And the wildest part is that it's even smaller than Jupiter. So why hasn't Jupiter turned into a star? Luckily for us, even though this gas giant weighs twice as much as all the other planets in the solar system combined, its mass totals only 1/1000th of the Sun's mass, and that's not nearly enough to kickstart nuclear fusion. But not all stars play by these rules. For instance, another contender for the longest name, PSRB 0943+10, might be the most mind-blowing star in the universe. This pulsar, made up of neutrons and an insanely strong magnetic field, rotates around its axis in just 1.1 seconds. The most astonishing part, though, is that the star's radius is only 2.6 kilometers. That's less than 4 millionths of the Sun's radius. Yet despite being this tiny, the pulsar emits enough radiation to wipe out life on Earth. Unfortunately, this record holder is doomed to a sad fate. It will gradually stop spinning, and its temperature will drop until all that remains is a dead core. But among the cosmic record holders, one marathoner refuses to die. I'm talking about a supernova in the Ursa Major constellation known as IPTF-14HLS. In 2014, a team of scientists from the University of California, Santa Barbara, noticed the explosion of a supernova over 500 million light-years away from Earth. Initially, it seemed like an ordinary event until the explosion happened again. And again. And again. Over the next 1,000 days, scientists observed 5 peaks in brightness, each equivalent to the formation of 5 different supernovae.